Find the area bounded by the x-axis and that function on that interval. End of sentence, we could go ahead and do that. So we could go ahead and find the area bounded between this graph and the x-axis on the interval from -6 to -3, which would go from -6 to -3. Check it out, check it out, check it out, out. I'm gonna wrap while I color. I'm gonna color outside the lines. Gonna do too much there. Gonna have to erase. Can't erase with this pencil. This eraser is old. It's older than my students. It's true, actually. I've had this pencil since college, or shortly after college, before any of y'all that are watching this video, if you're a high school student, were ever born. Because it is a, in case you care, skip the next 10 seconds if you don't care. North Carolina Teaching Fellows, it is a program that I was involved in when I was in college. It's for potential teachers, and it went away for a while, and so this is from that era. So I am a member of an endangered species, Teaching Fellows. Excellent program. All right, back on topic. Find the average value of the function on that interval and the x values, plural, which are c values, at which the function is equal to the average value. So let's start with the first sentence. We're going to find that area, and we're going to find it not by hand, much fun as that would be. So first thing I want to do is find the area, and let's use blue. The area from -6 to -3 of our function, -x² minus 8x minus 17 dx. And that's going to tell us what this is that we just shaded with our antique pencil. Our antique pencil. It's not our antique pencil, it's my antique pencil, and you can't have it. So, by the way, math 9, in case you forgot the steps, you press math and go to number 9, it is the function integral. So -x² minus 8x minus 17. By the way, the answer is going to be negative. You know that, right? Hope so. Because we're going from left to right and finding the area under the x-axis. So even though area is not negative, we've been through this, even though area is not negative, computationally it ends up being negative, and it is indeed -6. So we have just finished coloring, talking about a pencil, and answering the question that was in the first sentence. Now we'll keep going. Find the average value of the function on that interval. The average value of the function on an interval. Okay, well, the average value of a function, we usually call it f of c. That is the integral from -6. I just left something out. We'll be all right. -x² minus 8x minus 17 dx. But I left out 1 over -3 minus -6. Basically, the width of the interval is 3. So all this stuff, you know what? Let's not waste our time. 1/3 times all this. We just found this. It's -6. So -2? -2. Let's put it in context. -2 what? What is -2? -2 is the average value, back to the very, very beginning. Remember this? This area equals this area. So where do I draw this horizontal line to have just as much undercounted as I do overcounted? And that line would be drawn at -2. So da-dun-dun-dun-dun, da-da-da-dun-dun-da-da-da. I pick up the pencil and I start singing, start rapping, beatboxing, ballet dancing. It's great. Okay, at -2, we have just as much area that we overcounted as we undercounted. And that's it. So, final answer, final question, is find the x values at which the function is equal to the average value. So we are going to find those x values, which are technically c values. So -2 equals this function. They did ask for x values, column C, column X. I'm not going to be picky on this one because they did say x values. So -x² minus 8x minus 17. At this point, we're just moving things to one side, factoring. I'm going to move everything to this side to make it positive. x², 8x, 15 equals 0. And you can kind of tell where it is graphically. So here, -3. Here, -5. We're about to prove it. X plus 3, x plus 5. X is -3, x is -5.